So let me welcome you all again to today's webinar on Life Science 4.0 IP protection for digital innovations in the life sciences. And we are really thrilled to have so many of you here. And the interest in this webinar has confirmed our expectation that this is a hot topic for life science companies these days. We see it in our own client base that we are confronted with a lot of questions in this respect. And I think, it will become clear in today's webinar what the implications are, especially in the life sciences for digital innovations and what the best ways are to protect them. Maybe before we start with the webinar, a couple of housekeeping items. And this brings me to the next point.
Yes.
Yes, to introduce these two fine gentlemen here to the left and right of mine. So I'm extremely pleased to have with me today Björn Brouwers, my fellow partner. He's an electrical engineer by training, studied electrical engineering in Dortmund, and then did his training to become a patent attorney and qualified as patent attorney in 2015. Yes, he's an attorney in our digital and electrical engineering practice, which traditionally, but especially in the last decade, has a real strong emphasis on litigation. So Björn litigates patents in the standard essential field, but all sorts of electronics patent litigation, where he is the patent counsel responsible for the nullity and technical arguments in the litigation. But then, of course, Björn has also a very active prosecution practice for traditionally tech companies, but in recent years, really more and more also other industries, right, which
Yes.
have digital innovation aspects. And this is where the idea came to maybe make an event or webinar specifically for the life sciences community, so that you get a bit more educated on what is possible and what is not possible in protecting digital innovations. And as you will learn from Björn, there are some caveats to patent protection in the digital space, especially regarding software patents and the ban of software patents. So that's why, in our experience, especially in the digital innovation field, also related IP rights, such as trademarks, designs, copyright, but also the protection of know-how becomes more important. And I guess also for you as life science companies, the digital innovation seldomly comes from within your own company, but you're really often confronted with situations where the innovation comes through an external partner. So also here contractual matters play maybe a bigger role than in the usual in-house R&D innovation process. And that's why we thought an attorney at law would be a great supplement. And we are, of course, proud and happy that in the firm we have excellent attorneys that deal with these aspects. And with us today we have Reinhard Fischer, an attorney at law, who just became promoted to partner, so effective January 2022. He will also be among our partner, and he's studied law in Düsseldorf, right? And then did his doctoral thesis in Cologne. He is also experienced from in-house secondments with different companies, perhaps well suited for today's topic. On the one hand, a consumer care company, and on the other hand, a tech company who does engineering and electrical services. So that's why I think also this aspect of your CV matches well today's topic. Before joining Kohaus and Florak in 2014 already, Reinhard was an attorney at a mid-size full-service law firm where he specialized on IP-related topics and also IT law, which also fits nicely to today's topics. There he also focused on doing IP transaction work, so related to M&A work of the firm. And since you're here at our firm, I think you've also gained additional experience also on the prosecution side and also on counseling companies on how to best protect their IP and innovations outside of patents.
Yeah. Thank you.
And maybe just a few words to myself, just for completeness. I'm a biochemist by training and a partner here in our life science practice, and focus on core life science patents. But at least in the recent 4 or 5 years, I would say we have had really a lot of collaborative projects, where, especially in the digital field, where all of our expertise is called for. Okay.
So
then I would say we can dive into the presentation.
To the next slide, yes.
And just to give you a heads up what is expecting you, as announced, the webinar is split into 2 parts. The larger part is on patent rights. So how can you protect digital innovations via patents, and what do you need to watch out for? What are the caveats that you maybe not yet be so familiar with from your traditional life science practice? In that part, Björn will speak about. And then in a shorter part, albeit that there are more bullet points here to it, Reinhard will walk us through step by step through the additional IP rights that might be relevant for protecting a life science digital innovation. And at the end, as I already announced, we will have enough time for a discussion, but for those who have joined late, please do also enter any questions you have in the meantime, or maybe products or aspects you're particularly interested in the Q&A tool, and I will alert the speakers to it. Yeah. So let's dive into the introduction section, just to give you kind of a flavor on of what we will be talking about, or to set the scene, so to say. This slide is just to demonstrate the level of complexity and also maybe the historical development or the development stage of a life science product where digital innovations come into play. And maybe just as a historic backdrop, you see here the 1.0, 2.0, 3.0, 4.0. I mean, that refers, of course, to the industrial stages. So to say, we don't need to go into the definitions, what this means, but I think it's clear to everyone that the times are over where you developed a single product, be it a consumer care or a nutritional product or a crop product or a pharmaceutical product, and this was it. It already changed in Industry 2.0 with the Industrial Revolution, where assembly lines and mass production came into play, and then 3.0 is, I think, used for the globalized and computer-driven economy aspects of manufacturing in particular. But now we have reached the Industry 4.0 space, and this returns again, or has more nexus to the actual products, because this, in essence, refers to, I guess, the enhanced networking of devices and user interactions, right? Or the environment with the product and vice versa. I mean, this is kind of the historic landscape. So I think today probably, there are very few sectors or companies that can completely ignore the digitalization aspects and also the expectations that customers and users have in this regard. And then on the lower scale, this triangle there, we just tried to maybe depict or to help think about product development. There, of course, also the digitalization may also be part of the life cycle management of a product, that initially you develop the core product, I don't know, an active ingredient or something, a new one, and then you think about production ways and so forth. But in the end, oftentimes marketing or your business people in the company will come to you and say, we need a digital aspect, maybe an accompanying app to the product, or to bring some digital aspects in. And there is where the different disciplines also from the patent attorney side come in, because you're suddenly, as a life science patent attorney, faced with the question, can you obtain protection for those digital aspects of products? And there, Björn, right, you just put some bullet points here of examples that could come to mind.
And I mean, all of you know the classical apps as one of the main applications of the digitalization. And I mean, the classical app simply is executed on a smartphone or a computer. And then what we have in the digitalization is that information are exchanged back and forth between the client device and the server device. And I mean, this is the most general form, I think, or I can think of, which uses such software aspects of patents. And oftentimes we have questions here regarding how the protection of such apps can be done. And then on we have smart devices. I mean, smart devices, of course, have some software to it that they use, but they might be have different aspects like sensors or so on, which have an influence on the current application here, for example, with regard to more typical life science products. And there's the user interaction and the diagnostic devices, which may be also utilizing sensors. I don't know, for diagnosing basically everything, right? And
for monitoring status of I don't know, crop fields or whatever. There are really a lot of applications where you can think of sensory or diagnostics devices in the system. Yeah, and the last bullet point we put here is the digitalized production. And what we mean by this is that we have a typical production of products, and in the production you use different machines which are now more and more interrelated together by connecting them. I don't know, we are wireless communication connections or so on. And the reason we put this here is that you might have a typical traditional production, but you're using such wireless communications, and it may happen that such devices use, for instance, communication standards, which you might not be really aware of, because your main focus is that they work together and do the production. And now there might be situations in which you're utilizing like patterns of communication standards, which might be a little bit surprising for some of you. So yeah, right. So I think this whole digitalization aspect also presents new hurdles or challenges in Fto analysis, right? For life science in-house departments also, because I can say from my own experience, just listening and getting a feeling of the Fto project that are running here on the tech side, that it's really a different game. Just the number of patents that are included in these standards, and also these concepts of standards and standard essential patents is really very, very different from the Fto issues we otherwise see in the life sciences. And I guess that's maybe even an own topic for webinar.
Might be under consideration of the very, very large licensing pools and so on. So this might be a topic for the future. So so on to the next slide. So to pick this example of the apps, we have here on the left-hand side shown how such apps might utilize software aspects, and in which you might be interested in getting a patent protection for such digitalized or software aspects. And at first I'd like to refer to this diagram over here. And what we have here, we have typical devices not really related to life sciences, but they use the software in the form of apps. And then as a contrast, we have accessory devices like sensor devices, which might be connected to another device. And this sensor might be suitable to someone monitor or detect something with regard to a life science application. Or we have the integral part of dedicated devices, which might, for instance, typically be developed especially for the application, and which might not utilize such devices which are more situated, yeah, like in the personal surroundings of you, like the smartphone devices and so on. And we have the software interconnecting them, because all of them use the software aspects. And what we see is that we have standalone software which might not utilize any of such, let's put it this way, physical entities which are connected to a device. We have software integrated in the life science devices, and we have the accessory software for these devices, which might utilize like a personal computer in order to be able to utilize this accessory device in certain applications. And of course, this opens up not only the patent aspects, but of course, if you're in the medical field, there might be some medical regulations which might be considered in the development. And yeah, as just as one example, we have chosen here, this is the Cardia mobile app, which is an audible recording of the electrocardiogram. And this utilizes the smartphone. So we are somehow situated between the accessory device, which might be the device performing the actual recording, and the other device, which is the smartphone, and the software may be on part of the accessory device. It may also even be on part of the smartphone or both. And yeah, just to give you a short overview of how the different fields might be interconnected to each other. And then another example, which I found quite interesting, is a classical video game, which can be played by kids. And the video game is designed in such a way that it might treat ADHD symptoms in children. And I think this is quite a unique way of using a video game. But please don't ask me how this works in detail.
But it's of course also a very challenging aspect from a patent law perspective, right? Because the video game as such would not be patentable, but apparently here it's a medical use, so a medical treatment by the video game. And you see that there's, of course, the device showing the video game, and there's interactions with the user. So we will look into this more in detail.
Yes.
Yeah, I mean, today we have also participants, as I said, from a quite diverse set of life science companies. That's why we just put some additional examples just to set the scene how diverse possible applications could be. I mean, to pick an example from the nutrition consumer related industries, there are a lot of nutrition or lifestyle apps. You can imagine that you have an app where you record, or even a device records some body or vital parameters. You enter them, and then the program calculates for you or presents to you a custom built nutrition plan, for example. But then it would also bring maybe motivational content or something in addition there. Then also always the question is something like that patentable?
Yes.
I think what's more tech driven are aspects of agriculture. So there we also see really a great increase in patent filings for smart farming or precision agriculture applications. And then there are really so many different applications to think of. I mean, we see it here in the picture. It's often about devices such as drones or sensory devices on the machines monitoring crop fields for diseases or for any signs that signal necessity of treatment. And then also the application of the treatment of plant protection product or the insecticide or so forth can be much more precisely targeted to the actual infected plants. And then you can have a software that interacts, for example, with the weather forecast and controls the machine driving on the field. So also there we have a lot of these, I call them now like system claims or system setups, where you have different entities, different devices, sensors interacting with users via software.
Yes.
So that's, I think, maybe the connecting theme that we will talk about today, because we need some connecting field, because of course the various industry pose their own problems. Yeah, and this slide just is the final one of the introduction part, just so that we get an overview of what there is, what is out there. I mean, we already alluded to the fact, and we will hear more about it from Björn, that there's no denial that certain innovations are just not patentable, right? So pure software source codes, or also business methods, where we get a lot of inquiries also from startup companies, really innovative ideas, where the question is, can you patent this business method, and while that's maybe possible in the US, in Europe, it is generally not. But there now the full bouquet of additional IP rights come into play, and we see that for these these applications where patent protection is at least questionable. I mean, Björn will tell you that it's always worth a try, at least if you have some sort of technical feature, but it's definitely worth thinking about how you can achieve supplementary protection by a comprehensive set of complementary IP rights. And there, I mean, the utility model is very similar to the patent, but there especially copyrights, trade secrets, trademarks, and designs play a role. And here we will have the second part today from Reinhard, where he will guide you through each of these IP rights.
Yes, and which are of particular importance in case you might come up to the conclusion that a patent application might not suit your certain case here. So yeah, this is quite interesting topic to expand your portfolio in this regard. Okay, so then now on to the patent part. And I mean, of course, we start with the Epo guidelines in this regard. And I think most of you might, or you may know that the computer implemented inventions is one which involves the use of computer network, or other programmable apparatus. And one or more features are realized by the means of a computer, which is then the classical software aspect. And such computer programs are excluded as such from the patentability. So if you try to claim a computer program and try to describe the different functions performed by the computer program, you might want to not file a patent application. But of course, the exclusion does not apply to computer programs having a technical character. And at least in Europe here, there is like a two-step approach how this can be handled. And the first hurdle is that the claimed subject matter must have technical character. And this hurdle is quite easy to be overcome. And it just means that you need specific apparatuses involved. And if you have a computer with a processor and memory, then you are technical per se, because the processor and the memory enables to perform the steps, and they are physical entities performing the steps, and so you're not claiming just a computer program. So the first hurdle is quite easy to overcome, simply because you're claiming a processor and a memory, for example, or means for performing such steps, which is also enough in Europe to overcome such the first hurdle. And then in Europe, the second hurdle is the examination of the further requirements, which is the novelty and the inventive step. This is a little bit different here with regard to the computer implemented implementations in comparison to the German patent law. In Germany, you have another hurdle here introduced, which is that you need technical means for solving a technical problem, which is the question to be answered here. And in Europe, this is different. This is part of the inventive step discussion. And so thing to remember is to meet the first hurdle, you need some kind of technicality, which is simply a technical entity which is involved in the invention. And the second hurdle, this is what I will tell you now. So
it's more complicated.
And it's a little bit more complicated, right? Yes. And the thing is that for overcoming the second hurdle, only the features that have a technical effect can be considered in the inventiveness discussion. So of course, these features must be new in view of the prior art, and they also need to be technical. And what can be done in the problem solution approach is that if there's no difference, of course, with the prior art, you have a lack of novelty objection, and then yeah, you might use some features of the description. But of course, I assume that we have some features which are novel, and then you go feature by feature and check whether there is some technical effect involved. And what you need to do is that you have to look out for whether technical means are utilized for performing such features. And the problem here is, now I directly come to the bits and bolts of the classical app solutions, is that if you only have the app solution of a processor and a memory, or a client device and the server exchanging information back and forth, of course you have technical means involved. But those technical means are only the client device and the server. Mm-hmm. Sending and receiving information, and in what you try to argue is might be the information per se is totally new. Such information have never been shared and not utilized in such a manner. But this is like totally irrelevant in this regard, because the technical effect achieved here is simply a sending and receiving of information, which is well known. And then of course you have a lack of inventive step. So, and if you have a technical effect, which might be something in another physical entity, because you get data from a sensor device, or you use the data to control or regulate another device, and then yeah, the chances are quite increased. So yeah, I think this is for the second hurdle. I mean, we can't give you a clear answer how this might be overcome, but we try to give yeah, some examples to get a feeling what is considered technical, or where the technical effects yeah, can be comprised. So what we always recommend to do is yeah, to use a block diagram. And here I've drawn a quite simple block diagram of typical yeah, inventions involving different devices, which yeah, are related to the digital aspects. And what we often see is that there is some kind of sensor device, you have some kind of mobile device and a server, and each of those entities shares information between each other. I mean, we've drawn some double arrows here with data, but of course it's not required that the sensor device is utilizing a user to input data for the sensor device or into the mobile device. Of course, the sensor device can also provide information to the mobile device or directly to the server. But just to give you a feeling how you can look out for the different interworking of such devices. And each and every of those devices might utilize software. I mean, here in the block diagram, we've drawn the software directly inside the entity, but of course, the software might be performed on some kind of other device, and the device then simply retrieves information from the sensor device or so on. And what this really helps here is that you can see how the interaction between those devices is handled. And the reason for all this is that oftentimes the technical effect which you need for the inventive step discussion might lie inside the interaction between the devices, which shows how other physical entities or physical technical entities besides the processor and memory aspects are utilized. So that really helps to yeah, identify the technical effects which might be achieved. And another reason why such schemes are quite helpful here is I will give some more details later on with regard to the claim drafting, because this helps to identify the perspective from the different entities involved, and then you are able to draft the claims from the perspective of just a single apparatus, which really helps in infringement situations. So because you're yeah, not required to show in the infringed product that each and every, and I don't know, multiple different entities do this and this and this and X steps. So this is really, really helpful. So
yeah, maybe this diagram, because you mentioned infringement, is maybe a good point to just briefly sidestep with this remark that, at least from my experience, I can say, seeing all the litigation going on in the firm in this area, that these kind of complex systems with servers and devices and databases and users is usually much more complex than in the classic life science litigation, and also topics such as divided infringement over country borders also plays a much bigger role, because maybe some of these steps that you see here in the block diagram will not be carried out, for example, in Germany, right? So that's also why I think, especially in the tech field, there's a lot of case law on these aspects, and I think especially in this field, it's important to look to what types of claims will actually help you in the end when it comes to enforcing these patents.
Yes.
And that's something we also do a bit in the life science group, but not as much as you do, to invest kind of in this knowledge and in internal guidelines from the litigation proceedings to really think about what can you do better in terms of claim drafting to avoid common pitfalls in litigation in these tech areas.
Yeah, and I mean, one last thing to mention is, of course, such a block here might not even be seeable from the outside. It might simply be a module or a chip or something like that. And I don't know, you buy a certain device, use it, and then there's a component inside of this device which might be subject to patent infringement. So yeah, quite interesting topic.
Okay, but this is very abstract.
Yes.
So let's maybe dive into a couple of examples, but I must warn you, I think the claims are always very complex.
Yeah, a good claim is a page long. No, just a joke. Of course, we try to draft it short, but not always this is possible. So okay, so then yeah, for the examples. Here, I mean, some additional examples like the Cure app or My Sugar app. And of course, I included the digitalized production here. But what I like to tell you here is that that a lot of such apps are filed as PCT and US applications, and not yet many of such applications are granted in Europe. And I mean, one of the reasons is, like I told you in the beginning, is that they might be simply not based on an inventive step, because all there is involved in such apps is that the client and the server device communicate with each other. And but I mean, it's quite interesting to see how such software is utilized even in the life science field. And this is really interesting that it like swaps over to personal consumer devices, utilizing like the thing with the sensors and apps. And I mean, blood sugar monitoring or something like that is quite well known. And I know that my grandmother had also such a blood sugar measuring device, but I think nowadays it's quite interesting to see that you can track your history on part of an app and something like that. And yeah, so a lot of different fields, and I think more and more is developed in this regard. And of course, there's quite a large interest in how to protect such aspects. And the other point with the standardization patents. Yeah, I mean, we've talked about it, but just for the sake of completeness, that this is a really large field which interconnects different fields together. Yeah, it's quite challenging and interesting. So
I just interrupt you. I just got a question for those of you who joined late. Just the announcement that the slides will be provided after the webinar, and actually also the recording of the webinar part of this webinar.
Okay, yeah, good to know. Okay, so yeah, then here we've picked an example of a patent in Europe which is granted, and this is a suicide risk assessment. And this is just to give you an impression how the block diagrams interact actually with the claim. So what they included in the patent is thankfully a good block diagram where you can see.
So you also include these block
Yes,
diagrams. So
of
it's
course.
not just for your draft purpose, but you include them as figures in the patent application. Okay.
Yeah. And oftentimes we do a high level block diagram and then dive into detail. So yeah. And what we see here is that we have the suicide risk assessment engine, very fancy name, and some databases which use biological markers, and such markers might, for instance, be gathered by I don't know, different tests or sensors, or they might be even gathered quite manually and then entered into a database or something like that. But you have the thing that such data of the database interacts with the engine, and then you can use such information and check when compared to some kind of locations to assess such a risk. And I mean, I will not dive into too much detail here or the certain wording here, but what is interesting here is that in general there is claimed a computerized system for assessing a suicide attempt risk. And so we have the buzzword of the computerized to introduce such technical means, and then this gets picked up with computerized means for receiving biomarker data. And then we have the computerized means which really relate to the processor memory aspect for generating, I don't know, different sort marker scores and so on. And then there is computed or calculated a sort of value which is compared to another value to be able to indicate how a suicide attempt risk can be. And what is done here is that all of those technical means are defined, and then in the claim it is defined how the technical means interact with each other, to somehow show that there is more than a simple exchanging of information between the different entities, because they're using the information to determine a certain kind of score, let's put it this way, and then use the score independence of indication to output this I don't know, warning or alert to a user. So and this is quite usual to do it this way. I mean, what could be done a little bit different here might be that you claim it from the single actor perspective. But I mean, if we do the two hurdle test here on this patent granted, obviously both hurdles are met. Otherwise, we wouldn't have the granted patent. I mean, the technical means, yes, in the generic term computerized system already fulfilled. So this is done, okay. And then the second hurdle, we have some novel features, and according to the convict approach, this is the one where you check each and every feature whether it involves a technical effect, and then when it has a technical effect, it can be considered in the discussion of the inventive step, and then you check whether or not this is obvious for the skilled person. And here the technical effect is more than just the simple sending and receiving of information, and obviously it was considered to be grantable.
But the technical effects were not about the interactions of the different modules, but it was related to the actual, I call it now invention, the idea to have a suicide risk assessment in the computerized system, or do you think they relied on actual technical effects?
I think I think they somehow relied on at least technical effects in this regard, that you are really utilizing information like the biomarker data to get another output which has some sort of value.
But this you would consider technical to use based on data.
Yes.
Okay. Mm-hmm.
I mean, the better thing is when you have data which you can output to a physical device, really a technical device which you can control. But it might be enough if you have technical information as an input, and then using this on part of the software to, I mean, somehow generate only information for a human or a user to be utilized. So,
Because maybe as an anecdote, what we've seen in the classical life science field that we now get in some diagnostics patent cases, objections, so patentability objections in oppositions. So due to this exception that they say, although the patent was never written in any way intended to have computer systems carry out the steps, that the patents are old and were written in the sense that a lab technician would perform out a step. But then the objection is that theoretically on paper here, this could be performed by a computer program. And that's why it should be objected to. So I'm really curious to see how that line of case law will develop.
Yeah, you never know how this develops. I mean, who would have thought 2 years ago that it is possible to do oral proceedings in inter partes proceedings without the content of the party? So you never know. Okay, so okay, and then I would come to a quite interesting aspect, because what we I mean, this happens quite a lot, is the thing that you have a feature which is not known from the prior art, and which has some kind of technical effect. But then it happens that the technical effect achieved is matching quite exactly to what is claimed actually by the feature. So just to give you an example where this happened, there was a plugin performed by many different computers, and the plugin needs for updates, some authorization, and it was quite a lot of work to authorize each and every party that wanted to update the plugin. And then what was done was, of course, they tried to centralize this on a server, and the server does all of the authentication, and this was the feature. And the technical effect, and of course, this is the only feature which is considered in the inventive step argument, is that there is a centralization of the authorization. And then the technical effect is the centralization of the authorization. And I mean, also the objective technical problem to be solved is the centralization of the authorization. And then, I mean, what do we? I think this is from the TV. Sorry. So,
okay.
And then you come to the conclusion that it cannot be inventive, because really, when the object is a solution, you have a problem. So, and what they did to come up with a solution is, and this is how I think it's handled in the real life scenarios. There is the boss telling the engineers, "I want that it's more cheaper, or it can be done quicker." And then the engineer comes up with a solution of thinking about the centralization. And to get a more clearer distinction between such business-like objects and actually the technical object, then there is the approach of the notional business person. And the notional business person is incapable to perform any technical considerations. And this helps to distinguish more that the objective technical problem to be solved cannot be the one actually achieved by the feature, or claimed by the feature, not achieved, claimed by the feature. And yeah, this is an interesting concept, and that this helps in solutions which are quite close to business methods and have only some few features which have a technical effect, to be a little bit closer to the real world, and see how much consideration of the skilled person need to be involved to consider this obvious or not.
So the notional business person comes into play in addition to the skilled person, but in a separate test, right? I mean, yes. In the life science, we are very used to teams of skilled persons, so two different skilled persons, like a chemist and a biologist. But that's not what it's meant here, right? The notional business person kind of carves out the business thinking of the skilled person, so to say.
Yeah, and he really, it helps that the skilled person really does only the technical aspects and not really the business aspects, which might be the motivation to come up with a solution. Okay, so then as the next part, we have talked about all the technical effects and what is technical. So in the next slide, we have some examples of features, tasks, and effects that have been considered technical by the Epo. And this is quite interesting to help to develop a feeling where those technical effects might lie. And I mean, of course, we have the technical classical field effects in telecommunication of transmitting data, or I don't know, modulating the data or decoding the data. And then you have this technical effects, and what they do is they improve the security and reliability, for instance, of data transmissions, or they help to reduce memory resources when the data is encoded in a certain way. And the reducing of memory resources or of the data size to be transmitted can help in a lot of different things. They can help on part of the device because it doesn't have to store as much data. It can help for the transmission because not so much data has to be transmitted. The transmission might be faster or might use a slower connection, which might be more reliable and so on. And what is interesting here, if what we do, if we have these questions with regard to the classical apps, oftentimes when we check how actually the data is handled, there might be something in it because they try to really optimize how the information flow happens, right? And then there might be a technical effect besides the sole transmission of data, which lies in the interaction, which is handled quite in an effective manner because, I don't know, responses and or answer messages can be reduced, or the data is arranged in a database for easy and quick access, or to sort is in a certain way. And this might help to really identify some technical effects which might lie on part of the software and might not be known, or so, and even the inventors might not really aware of it because they think, oh, the technical thing is the app that I developed. So this is really interesting. And what this shows is that when you really look at the diagram and try to re-engineer how each and every data is handled and within the devices or the modules and between the devices, you can really see how or where such technical effects might be. And of course, what also can be present as a technical effect is that the software, I don't know, calculates a lot of different parameters for some components to make them more stable or something like that. And this might also help because we have at least an indirect technical effect on which is then present in the actual product. And I already mentioned improved resource usability in a lot of different aspects. And this is one here, the saving energy. This is often a good technical effect because we have the field of using like mobile devices in each and every form. And a big role is the battery power because nobody wants to charge the device, I don't know, twice a day. And if you can perform your method in a way that you're still aware, I don't know, of each and every information, but you can save energy because you don't have to, I don't know, utilize the transmitting device so many times. So this also helps for and is a good technical effect.
But the way I understand it is that, going down this checklist or thinking about these things is also one of the core tasks of the patent attorneys, right? That's at least my feeling in the life science field. We pick our brains, thinking about non-obviousness, because often we have really borderline inventions where you think they would be obvious, and we think about, arguments why it could be non-obvious or teaching away elements. And this is kind of our daily bread, so to speak. Whereas in your case, I think discussing with the inventors is often about, so it's more that you also come up with
the technical
suggestions.
It depends on the client. If the client is quite experienced.
Yeah, but I mean more for the life science community here, where the inventors would not have much experience with filing tech patents. Probably,
of course,
you would also be suggesting or questioning them, trying to brainstorm if there's anything that could maybe relate to such more yeah, technical.
But even
aspects.
in an, I mean, I think, but this helps even in internal reviewing processes when you try to which applications to choose for the filing of the patent. You can quickly go through and think, oh, there might be something in it, or then specify the invention we want.
What's this last point, the technical effects related to hardware components? So is that always automatically technical if you have some impact on a hardware component?
This might be in a lot of different ways. One way is, of course, that you're controlling or regulating some kind of hardware component. I don't know, like turning it off and on certain occasions to save battery power, or to, I don't know, change it, or a mechanical component that it does a certain movement or something like that. Yeah.
Okay.
Okay. So then we come to the claim drafting. When you have identified what you might consider suitable for a patent application. In our most recent experience is that, you have, of course, different claim categories, like the method claims, the apparatus claims, the computer program product claims, or computer readable medium claims. And what, from the infringement perspective, the apparatus claims are the most valuable, because those are physical devices that are utilized by the people, and they might perform the certain steps. And what I want to tell you here is that it is indeed possible to have more than one claim of each claim category, because oftentimes you have like a sender-receiver interaction between the devices involved. And the lack of unity objection might not really be a problem. And but of course, also, like we mentioned earlier, the system claim is quite an important one, which ties together different apparatus and the interaction with each other. And we always try to do in the first step a really general kind of way to claim the methods. Personally, I like to do just a simple method comprising and then doing all of these steps, or the apparatus comprising means to perform the steps. And what I wanted to show you is here as an example. If you have a solution where you're using a mobile device and a sensor device, from the way in which we would approach such a claim drafting is that we would look at what really does the sensor device and then claim it in this way. I don't know, the sensor device might gather some measurements and then output the measurements. And then we look what the mobile device does with it. The mobile device gets the measurements, then, I don't know, it performs some calculations or determines some values, and then the mobile device might output, I don't know, feedback to the sensor device, and the sensor device might, I don't know, adjust in internal threshold or something like that to optimize really what you want to see in the measurements. And yeah, then it goes back and forth, and we try to claim it in a way isolated from each other, so that you only have the mobile device performing the steps, and then we have another apparatus claiming what the sensor device really does.
And is your impression that this tech field is a particularly fast-moving field, where also, you know, definitions and meanings for certain terms and claims change over time?
Yeah, they might.
Because my impression is always that it's very abstractly formulated. And I wonder what the reason for that is. Is the reason because, you know, you don't know if maybe in 2 years the mobile device still is a mobile device?
Yeah, I mean, to put it in this way, yeah, it might be, but of course it helps to future-proof this claim drafting, because you're using the generalized term. I know, simply you're not really defining that you're utilizing mobile network of, I don't know, new LTE standard or 4G, 5G standard, because you're trying to even cover, I don't know how they call it, 6G, 7G or 8G standards, and there's still mobile networks, right? But
that's rarely objective too. That's not this problem, this level of abstractness.
No, I think you can be more general than you think, because if you simply have an impression how this might be able to be done, this is oftentimes enough. And our clients, in particular in the communication business, really likes to have it as abstract as possible, and only define it in case it is really necessary. I don't know, for validity.
Yeah, I mean, for the people listening, maybe the alternative strategy is also good to not call all those tech giants on the radar, to keep it more restricted to the actual life science application that they're handling with, because as you already alluded to, the litigation field is really very
but I mean
as we just saw in the automobile industry.
And another thing which helps when you are a little more specific is, of course, that the prior art is a lot smaller.
Yeah.
Okay, so then on to the next slide. And I mean, this is just a summary of what we mentioned here. And for the infringement perspective, I like to put the emphasis on the single actor claiming, which really helps to avoid the divided infringement situations. And what I also recommend is the future proofing by using generalization of the terms, at least in the very first.
So that's what I was alluding to, right? This is what you call future proofing. Okay.
Yeah, quite a fancy name. But
so single actor means
from the perspective,
not the system claim, or the system claim from the perspective.
No, not the system claim.
You want to avoid system claim.
Yeah, more or less. The most preferred ones are single actors of a single apparatus performing the steps. But of course, if you need more than one apparatus, because the apparatus really does not do much, right?
Yeah.
Then of course sometimes you have to rely on the system claim. I mean, in the patent application, you can simply write a paragraph about the system claim in claim-like language, and this is often enough.
But I mean, these recommendations count for innovations where the actual innovation lies more in the software aspect, and where you're trying to get technicality. I mean, if you have a really new device,
of course,
like a new insulin pump that also has smart functions, but that's, I mean, just to be clear about that, that's of course patentable as such.
Yeah, of course.
We are talking here about the borderline cases where, among us, honestly, the major innovation is often in the actual software aspect, but where you try to achieve patent eligibility.
That's totally right. Yeah. Of course, classical devices are always,
even if they're electronic, or if they can interact with others.
Yeah. Okay. So just this is a summary of the claim drafting as a practical advice. Identify the technical features. I don't know. Check whether or not there is even some combined technical features involved between the dedicated steps that are performed, and then you can draft around such the technical effect in order to have a good cover of the application. And I mean, this is something I mentioned not really explicitly, but of course in different jurisdiction a certain language is preferred, and at least for US and Europe, we always suggest to really spend some part of the description on the other jurisdiction that you might be interested in. So this is done quickly and helps a lot in the future. Okay, so any questions so far? But of course, I'm here after Reinhard's part, so maybe there might
maybe for those of you who have joined late, right, it's possible to pose questions via the Q&A function, and we can address them in the webinar. But we are definitely planning on at least 20 minutes, 30 minutes, half an hour at the end, where we can have an open discussion, and where you can also join by activating your microphone. But if there are any questions now, feel free to write them in the Q&A function or in the chat. Otherwise, we're just switching microphones, and Reinhard will turn to the soft IP aspects of software-related innovations.
Yeah. Hello again from me. Soft IP means non-technical IP, I think, and what you will see with regard to the other IP rights is that of course, if you want to secure that a technical solution is not used by competitors, then at the end, the only way is the patent. But I think in digital products, there's much more than only technical solutions, and there are big assets and assets of big value which are not technical. And I believe that companies like Facebook and so on, mainly their value mainly depends on algorithms and data, and not on patents, but also on patents, of course. So we start with an overview, but it's more not an overview about the rights, but more an overview about the aspects that may be relevant for the non-technical IP rights. And therefore I use this graphic, which we are already used, but highlighted some points which may be more relevant here now, because it more depends on how the user communicates with or gets in touch with the product, because there is their trademark and look and feel of a product which might be relevant for protection. And then other other aspects which are more in the background, like database and software, which may be relevant for the non-technical IP, because as we learned, of course, software can be an aspect of patent protection, but not the software as such, and also data cannot be basis for patent protection. So it's a question, how can I secure such aspects which may have a bigger value? And I picked out the assets that may be relevant here. This may be the name of a platform or app which the user is using. It may be the look and feel that I have from this on this platform and in this app. It's big data and AI data and other data, which it's also user data, which is relevant for the products. It's the algorithm which is behind it, and it's the software that is used. And so for the first aspect, the name, we have the trademark, and there we have some certain challenges from digital products, which you might not, which you have to consider. You have now main products and main classes for which you are protecting your trademarks. Maybe class 5 for pharmaceuticals or class 30 for foods. And now when you are offering digital products or services, you may think about that there may be other classes that are relevant here. And the basis is that when you apply for trademark, you must, this application must contain a list of goods and services where you mention the goods for or service for which you wish to use a trademark and for which it shall be registered. And why is this relevant? Because after a certain time, the trademark must be genuinely used in connection with the goods and services for which you have registered the trademark. If this is not the case, then the trademark may be revoked, and therefore it's of course important that you think about what is the product or the service, what you are offering now. And in this regard, another aspect which may be relevant, because you're still mainly selling pharmaceuticals or foods or something like that, there's a question: is this digital product, is this only a side product, or is it also main product for you? Because if this is a product which you only use for advertising a main product, like for pharmaceuticals, publication of medical information, I think this is more or less a side product, and it's just to advertise your main product, or has a side product and own value. And in this regard, it's not relevant if you generate profit from it. But this is always in between. If you had only use it as marketing tool, or as in connection, it's only marketing product, a giveaway, then you do not use the trademark for it. But I think the digital products or services mainly are used in the future for generating profit, and so this may be then the main product.
But it probably doesn't hurt to include additional classes, right? I mean,
definitely. That is
The worst case can be that later on it's nullified due to non-use, right?
Yeah.
Or you can also drop certain services if you to do a broad filing in the beginning. Probably makes sense.
This doesn't harm you. It may there may be some more costs at the beginning, but of course this is worth it. And definitely the recommendation is to have a broader list of goods and services. Also, I come now to an example where it's not clear what is the main product, and so also in this case I would recommend to use several classes and terms, so that you have not the problem at the end, and then only the trademark will partially revoked, but you are quite sure that the product or services for which you use the trademark are still in it, and for this the trademark is maintained. And this is an example we already use, and you see in the text that you can think about, what is it now, what you are offering? Is it a medical treatment? Is it a software? Is it then I see there is it's computer based, and therefore it's not clear here. Is it a product or is it a service? And if you use the terms that the office typically uses for the product and has in this classification database, then you see that there are certain products and services which can be relevant here now. It's mobile apps of class 9, or medical devices still of class 10, or if it's mainly an internet platform you're using and have access to, then it may be class 38, and therefore you see that that it may not be clear, and it may definitely be other classes than you are used to. But the clear recommendation is maybe to include some more classes to be on the safe side. So the second is a design. I think this is something which I can make rather short, but of course if you have an app, as you see here, there are some graphics, there are icons, there's a user interfaces which sets a certain look and feel, and makes you connected to this original, it may be original product, and if you see it, you are used to it, and therefore you may have the interest also to prevent others from using similar graphics. And this is something which you can also protect by trademark, but complementary, or sometimes primarily by designs, because designs you get for the appearance of a product which is new and has a character. And such products are also graphic symbols and icons, although they are two-dimensional. But in Europe, it is clear that you also get design protection for two-dimensional product. It may be different in other jurisdictions, but therefore it's worth to also make registrations on this basis. And the design protection is rather cost efficient. It's rather low cost, because the office does not check whether if it's new and if it has individual character, and therefore the office fees are rather low.
But how do you go about in practice? I mean, if you have a physical product, it's pretty clear how the design application would look like, right? You have drawings or photographs from the different perspectives of the physical product. I mean, you see it here already on your examples with the user interfaces. I mean, you have the problem that you have a lot of different views on the app. You might have different pages, or I mean, do you put that all into one design application with different facets, or is each of these an own design?
Each of this is an own design. Of course, the whole graphical interface can be one design, of course, if it's presented to you as a whole, but also each icon can be an individual design. And usually you solve this by making collective design applications. And as you see in the example on the right, each icon is a sole design. This is a single design.
Yeah, so also there you go a complementary approach that you try to protect the individual elements by individual icon design protection.
Yeah,
and then the graphical user interface as a bundle. So the collective design, for those of you who are not so familiar with it, is a bundle of design filings, right?
Yeah, it's but each is you have the collective application. This means that you have a cost saving effect if you put all the designs in one application, but at the end each of the design is a single application. But you can also think about if there is a interface with more than one icon, that you also secure or register it as a whole, which may have an advantage with regard to novelty then. But it's you decide on a case-by-case basis. But I think with regard to the icons, if they are new, then it is definitely worth to make a single application or in a collective bundle, but it's still a single design that is protected.
Okay.
So then now we come to the trade secrets, which I believe is at the end a rather strong aspect with regard to algorithm and data. Because all other IP rights in this regard have some protection gaps, but we come to it later. But there is not really sure whether how strong is the protection. But with trade secrets, it's rather clear that data can be protected as trade secret as long as it is kept confidential. And so your main focus has to be on keeping it confidential. And but if this is secured, then trade secret will grant a rather high level of protection by the applicable laws. And there you see in this overview what can be a trade secret, and there are some terms that we already heard today, and which are really relevant here. There's on the one side technological know-how, and on the other side it's commercial know-how, and both is relevant. It can be the code of the software, it can be algorithms, technical data, and user data, which can be secured by a trade secret. But what is important, and that this we will see when we go to the certain requirements of trade secret protection, that this is not an absolute right. It's you are have a rather high level of protection by law in case you manage it to keep it secret and to have a certain level of confidentiality measures. But as soon, of course, as it becomes public or your measurements are too weak, then you might lose your protection for it. So we see it here again where it might have a relevance, and it's a database and it's a software side where trade secrets may be very relevant. And the trade secret protection has become stronger, I would say, in the EU due to a directive which is now implemented in all individual states of the European Union. And that it has become more like an IP right by this. But in Germany it's more or less the same, because we had a rather strong protection by case law in the past as well, but now it's more clear in the law what does it mean, and I believe it's still a bit stronger also in Germany. And the most relevant section is section 2, which defines the information or which defines the trade secret. And it's basically information which is not generally known or readily accessible, and has an economical value, which is subject to appropriate confidentiality measures. And this the last point is not that relevant, also not in the EU right directive. If you have legitimate interest of keeping it secret, which is in most cases true. And yeah, you see from the definition, information is not does not seem to have a big threshold to be in information, and therefore information is also raw data, and it's definitely the collection and structure of certain information which is used in this digital areas. And which is not required is that is new, that is individual, that's creative or original. It's just that you have an information which is not accessible to other parties. And even if this is an old method you use in your company, and just the fact that you are using it, although it might be 100 years old, can be a relevant trade secret, and therefore there's no certain requirement. Just it has to be a secret. And but what is now new for Germany, but other countries still had it, is that you lose the protection for trade secret if you do not use appropriate measures to keep this information confidential. And that is not quite certain already. What does this mean? And of course, there's a lot of insecurity in the companies right now. What is clear is that you do not have to use best protection. It's clear that it depends on the circumstances. But what I highlighted here, which may be relevant in the digital market, where you have data and where you have algorithms which are used in network systems, I believe that what is important is that you have a technical access protection to the data. Of course, some data is used, and this is in a certain way becomes apparent to the user. But not the whole database that is behind it, and definitely not the algorithm that is behind it. And then if you, which may be definitely relevant for companies which have not their main focus on such digital products, they will have to involve other companies with which they may have to share the data, or they even use certain service providers that are hosting servers and store the data on it. And in this regard, it's very important to secure that that the data is kept confidential by them. This should be made by an agreement that is not too general, not only providing that each information which is disclosed shall be kept confidential, but to make clear, okay, this is now storage with data which is very, very confidential, and to make clear that only the persons that have a need to know get access to it, and maybe to also agree on a contractual damages, so that is clear that this is important confidential information. Another interesting question is who is the holder of this trade secrets, and also in the network with multi-actors and other companies you involve when developing your system or when you're offering your system. It may at the end not be that clear who is now the one that is the owner of the data, who controls the data, and therefore it's very important also at this point to have clear contracts which make it clear who is the owner of the trade secret. Even if it's originally owned by another company, it's also possible to transfer the rights in the trade secret to the other company. And therefore, in case I know that at the end I have a product which is based on data and algorithm, and there may be other companies generating it, then I can of course agree by contract that all the results of this is owned by me. Yeah, and what is then secured if you keep it secret and have sufficient confidentiality measures, then you are secured against unauthorized access. Yeah, if other parties get access to the information, what is basically or rather clear is if you breach a non-disclosure agreement, which is specific enough, then you have claims against the one who has breached the agreement, but also you may have claims against persons at a later stage that are using this information and who are, or ought to know that this trade secret has been obtained unlawfully. And in my view, and I think the view of also of other lawyers, it depends on the time when you are using the know-how. So you may be in good faith when you acquired the know-how from a person who disclosed it unlawfully, but when you are in bad faith when you're using this information, then still the trademark owner may have claims against you, which make it close to an IP right, or more close to an IP right.
But once the misappropriation has occurred and the person misappropriating not only uses him or herself, but actually publicly discloses the trade secret, is then the trade secret lost because it's then no longer secret, or is it sufficient that you have, established all measures to keep it secret?
Yeah, this may be also not clear, but I think in case it's really public domain, the trade secret, then it should be clear that you don't have the character as a trade secret anymore, because it's
so you're
disclosed
only with a damage claim against the person.
That's of course, yeah, with the damage claim, yeah.
The trade secret in a way, it's also lost. So even if you have this strong protection, also for that reason, it's really important to make sure that you do not lose your trade.
Yeah, it's of course it's very important to also have actual security, not only security by contracts or by law. You should definitely try to only share the information with the persons that have definitely a need to know if it's very important confidential information. Then because if it's in the public domain, then I would say there's no protection anymore. But if there is a party that is obliged to keep it secret but disclose it to a third party, and which is not bound by a confidentiality obligation, but which does not make it public and use it, then you may have the claim against this person as well. Yeah.
Okay.
And but that is now one point which makes it clear that a trade secret is not an absolute IP right, because what is not secured is that another part, if you have a digital product with lots of data and algorithm, but there's another company that is copying the business model and generating its own data and generating its own algorithm, and it works like your product, then it's not a misappropriation of the trade secret, because in the independent discovery or creation of such trade secrets by other companies is possible. And as well, and this is now clear, it was not clear before with the old German law on trade secrets, that reverse engineering is not an misappropriation of trade secrets, because and therefore it's of course important to have good technical security against the becoming known of your
and I mean,
data.
Also on the other side, right, thinking about the cases that you've been dealing with, it's often a question of evidence to actually prove that one has not misappropriated the trademark. So if you are a competitor or an interacting, collaborating partner, it's important, right, to really keep a track record of your own development stage and know-how, that you can prove later on that you have the know-how already before you started your interactions with the collaborating partner, right?
Yeah, that's definitely very important. and this is what for trade secrets and copyrights as well, because it's not a registered right. In case you make litigation based on an infringement of trade secrets or copyright, then you will have to prove that it's your trade secret and it's your copyright, and therefore there must be any kind of evidence when did you have the trade secret and who developed it, and so it's very important.
I mean, for some clients we even offer, I mean, similar like patent database or patent files. We actually open up kind of trade secret protection files or copyright files where you also put in a description and you have a kind of like a filing date or a documentation when it was, for example, submitted to the law firm for storage. Then you have a date. Yeah,
you have a witness, you have some kind of record data when it was sent, and and that is at the end is helpful to prove at what time you had what trade secret. And this in case you have a trade secret and it is infringed, then you have the same claims you have under patent. It's injunction claim, recall claims, information claim, destruction claim, claims for damages, and what is rather important, which came through the new regulation, which was not that clear before, but which is still something that has to be go over to the practical side. But the problem was always that in case you make litigation based on confidential information, you have to basically disclose certain confidential information in these proceedings in order to that the court can be sure that that it is a confidential information that's infringed, and the other party can make their defense against this accusation. And in this case, since all court proceedings are public, basically, this was always a big problem that confidential information may become public through this litigation. And there are now some regulations which make it rather clear that this is not a problem anymore, because there is a clear guideline also for the judges how to handle this. So now, the last part is now the copyright, which is a right which in Germany is also not registered. There's no possibility to register it, but the advantage is, and the good news is, that you are obtain a copyright with creation of the work, and there are no costs for it. But also in copyright, there's a problem that you at the end have to be able to prove the chain of title, that you are owner of the copyright, and there it's very clear that there is a creator at the beginning who is the original owner of all the copyrights, and this is maybe the software developer in your company, and there you have to be clear, or what's even worse, it's a software developer of a service provider which you use in this, and there you have to make sure that all what he created is transferred to you, and in litigation you should be able to prove the whole chain of title. But if this is the case, then you may have some copyrights also in digital products, mainly for computer programs or software, which is there secured as such, or database works. And there is a related database right, which does not require creative work. So the requirement is a bit lower, but also the protection is a bit lower. But the message here is that there may be maybe a copyright protection for aspects of your products, but you should be clear that it's essential to have agreements in place that make it clear that you are the owner, because also in case there are no clear agreements, then there's a rather strong right of the creator because the German law provides that if there is any, if it's unclear what rights were transferred, you always think that the lowest level of rights have been transferred. So you have to be able to prove that you have all rights in this software database or something like that. But in this case, then we see that software and database has an important role, and so that these databases and software which are in your network may be protected by copyright. But I think besides making good agreements, there's nothing you can really do to. At the end, it's still a side argument in litigation that you may also have copyright protection that have been infringed. But you have it by creation without registration.
But from the duration of the protection, it's the trade secret is kind of forever. It's
forever,
no limit to it. It might become outdated at some point or lost in data transition. But for the copyrights, right, it depends. So it could be up to 70 years after death of the creator, right? But for the databases, it's also shorter. 15 years, right?
There's another slide where it's, because there are two different types of rights that are secured by the German Copyright Act. The one is a real copyright, which needs there's a creative work as basis, and if there's a creative work, then you have a protection until 70 years from the death of the creator, which can be very long. But there are also this comes from EU directives which are implemented in the German copyright law. There are certain performances or certain products which are shall be secured as well, which have more, where more the invest into it is secured than the creative work which is behind it. And for this, it does not seem to be reasonable to give this such a long period of protection. And so it's shorter, and the database protection with not a creative work is therefore 15 years from creation. But if it's further develop this database, then the 15 years may begin successively again. So then one is the computer programs. There is
so that's explicitly mentioned, right, in the copyright
Act? It's explicitly mentioned. It's also from a EU directive, and you may say that it's not it's not like the other copyrights, because the threshold of creative work is not that high. So it's the idea that computer programs shall be basically be capable of protection, and so only very easy programs and which are which everybody would make in the same way, is not protected, but all other programs are basically protected. But what is important, that it is not the function of the program protected. It's a program code and the structure, the structure of commands that is beyond it. But if a competitor uses other software developers and instructs them to make the same function by new software development, then this is not protected by copyright. So it's only what was in the past also relevant. If I copy the Microsoft Office, then of course this is a infringement of a copyright. But I think in the digital world, the programs, I'm not a software developer, but in my idea, the programs are rather easy, and it's not the big cost to develop and reverse engineer and to make own developments. And so in this connection, it may be not that relevant than in other cases where even the software programming is a really cost factor. And the other is database protection, which is which is a collection of data, with independent elements which are systematically or methodically arranged, and where the basis is, if it's a creative work, the intellectual creation of a person, then you have the longer protection time, or it's a substantial invest you make for creating this database, then it's this 15 years duration. But in both cases, we have some protection gaps, which are not really clearly assessed by courts right now, and not by highest courts. That there was one, or it was unclear what does it mean elements must be independent. There we have now a decision of the European Court of Justice, which can be read as this is not a high threshold, but which may be a problem, or more a problem, is that it's the database is only secured if substantial parts are taken from this or are copied, and therefore, at the end you will have to see, in case you have a database and another company is using it, then on a case-by-case basis you may think about whether also this database protection may be infringed and use this as an argument. But if only certain data is obtained, single data is obtained from this database, then it may not be infringed. And so but also this is a IP right you may think about in connection with big databases.
Okay, this brings us to the end of the seminar portion. So thank you very much, Reinhard and Björn, for these very detailed and good presentations. As I announced, we will have a Q&A session now directly following, but if you have any questions also afterwards or after listening to this presentation, feel free to email any of us with questions. We are happy to enter into a new discussion also after today. And with this, the official part of the webinar is over. Also, the recording will be stopped here.